So hopefully that's not too bad. Does anybody need the screen, the warm-up problem up anymore before we switch? Okay, I'm going to switch to our notes from last class. So okay, so this is what we were doing last class, these combined events notes. Okay, so we did this whole front page together. And then I think we did one of the examples on the back together. And I said we were going to skip example 2 and that you guys were to try numbers 1 through 5. Are there any questions on 1 through 5 that you want to go through? So did anybody have any trouble? I believe I posted the solutions, and then within the solutions, number 3 and 5 had like the full written out solution. The other ones just had the answers. So any questions on 1 through 5 that you want me to go through before we move on? Okay, I'm going to assume that means that you guys totally understand 1 through 5. So we will move on to mutually exclusive and independent events. Okay, so there are 2 more definitions that we need to understand, okay? They're like more rules, and we only use them sometimes, but we need to understand the definitions. The first thing I guess we'll talk about is mutually exclusive events. Mutually exclusive events have no intersection. So the probability of the union of the 2 events happening is going to just be P of A plus P of B, because the intersection is 0. Okay, and I know that these were already posted, but I'm going to talk through them because we never talked through them together. So this can be used only when the event A and the event B have no intersection. So P of A intersect B is equal to 0. Sometimes you'll see it as like this, which is the empty set or the null set. It's saying there's no elements in the set of the intersection. Okay, what questions do you guys have about that? Okay, so we'll do an example. It says, given that X and Y are mutually exclusive, with P of X being 4/7 and P of Y being 1/3, find the value, and there's a typo here. Find the value of, it should be X union Y. Okay, so P of X union Y is going to be equal to P of X plus P of Y minus the intersection of of X and Y. Okay, that intersection though is going to be 0, so I can just write 4/7 plus 1/3 and subtract 0 from it. And when I find a common denominator, my common denominator will be 21, and I end up getting that this should be 19 out of 21. Okay, so again, this means that P of X intersect Y is equal to 0. Okay, what questions on that first example?
So is that how you, oh, never mind. That's not how you find the intersection value.
The intersection value for mutually exclusive events will always be 0.
Okay. I'm confused on how you do find the intersection value. If it just gives you like the outer two, it just gives you A and B.
So if it just gives you A and, okay, so we did, like, if an intersection does exist, actually we did it, I think, on an example over here. They would have to give you, like, they have to give you 3 of the 4 values in this equation. Like, you would have to know what the union was already. Does that make sense? So if you know 3 of these 4 values, then you could find the intersection if it wasn't given, but you would have to already know the union. They're just saying in this case, the intersection is going to always be 0. So there's no reason you would have to find it. Or if, like, you could just make the claim that they were 0 if you knew that they were mutually exclusive. So this one tells us kind of, it's a little bit kind of addressing your question, Izzy. It says, given that P of S is 0.34 and P of T is 0.49, and the actually that's the complement of the union is 0.7, are events S and T mutually exclusive? So it's asking, is the intersection 0? Okay. So this is asking the question, is P of T intersect S equal to 0? Okay. So if I drew out, I think that it would be helpful to draw out a little Venn diagram here. Okay, so of our 2 events, we know that the complement of the union is 0.17. The complement of the union is going to be like everything outside of these pieces. So all that blue stuff. Okay, and that blue stuff is going to be the 0.17 that they give in the problem. Okay, so then we would want to set up our equation as best as possible. So we would set up the union equation. So first, we are given the probability of the complement of the union. So let's figure out what the union is. So S union T is going to be equal to 1 minus the probability of the complement of S union T. Okay, so that's the complement. And that complement, hold on, where'd my, oh, here, was the blue part that they gave, okay? But we're looking for the union, which is going to be this yellow part, okay? So 1 minus the blue stuff is going to give me the yellow stuff. Okay, does anybody have questions on that?
I might have missed it, but where did the 1 come from?
So 1 is the total probability of any given event happening. So like everything inside this box, the total probability is 1 or 100%. Does that make sense?
Yeah.
So to find the yellow part, I have to take 1 and then just subtract the blue stuff off.
Okay, that makes sense.
Okay, perfect. So now when I take 1 and subtract 0.17, I should get 0.83. Okay, so that means my yellow stuff is 0.83, my union of the 2. So now that I have that information, I can set up my equation like I had on the other page. So the probability of S union T is going to be equal to the probability of S plus the probability of T minus the probability of S intersect T. Okay, and the goal is to figure out what S intersect T is. Okay. So we have now all the pieces except for the intersection. We have the union here. We've given so 0.83 is equal to 0.34 plus 0.49 minus the probability of S intersect T. Okay, Now, if these guys are mutually exclusive, then we will find that that probability of the intersection is 0, okay? So when I do all of the subtracting, I do end up finding that the probability of S intersect T is equal to 0. Oops. So we can claim they are mutually exclusive. Sorry. This is dumb. I'm trying to box it in, but it really just made it way messy. I should probably just rewrite it. So bad. Okay, questions on that example or anything with mutually exclusive events? Any questions?
So, I don't know. I guess I'm just confused about why there are two PS union T's that with different values.
This one is the complement of S union T. See how there's a little prime in there? And then this one is just S union T.
Okay, yeah, I missed the prime. Sorry.
It's okay. I mean, it's very tiny, so. Anything else?
So with mutually exclusive, the intersection is always 0?
Yep.
Okay.
Yeah. Okay, I'm gonna go ahead and move on to independent events. This document, written much more neatly, is already posted on Canvas, so you can go back and put a better image of the notes on the mutually exclusive side. All right, so independent events, okay? Independent events are going to occur, and I think that this one is a little bit more confusing. Well, I'm not going to even say that. I'm sorry. So independent events occur when P of A intersect B is equal to the probability of A times the probability of B. Okay. This can be used when you know two events are independent. Well, any given number of events. So I'm just gonna remove that. So when you know events are independent, okay. To check, if A and B are independent, you should check P of A intersect B separate. This is key. This thing is checking the two things separately is key. So, and I will take off points for this when I see it. Okay, so what you're trying to do is you're trying to show that these two values are equal. Okay, in order, and please, if you weren't paying attention, try to pay attention right now. In order to prove that two things are independent, you have to find this calculation, so like P of A intersect B, separate from P of A times P of B. You cannot set them equal right off the bat, okay? That is assuming what you're trying to prove. So assuming what you are trying to prove. This was the biggest thing last year I had so many